Hello everyone, I welcome you all to the third video of our course Newton's Laws of Motion. In this video, let us recollect what are the three Newton's Laws of Motion because these laws are the basis for engineering mechanics course. So let us revise. The Newton's first law of motion, it states that any body continues its state of rest or motion unless it is acted by some external agency of force. In this animation, you can see that the motion of the vehicle is stopped by the wall constructed here. Till then, the motion is continuing. So that indicates the existence of force. Now, let us see Newton's second law of motion, which states that the rate of change of momentum is directly proportional to the force which caused the change and will be in the direction of force. Here, in this animation, the momentum gained by the ball is proportional to the force applied by the man. If you observe, you can see. As per the law, let us see what is the rate of change of momentum, how it is proportional to the force. Rate of change of momentum is nothing but we know that mv2 minus mv1 upon time t, where m is mass of the object, v1 and v2 are the initial and final velocities of the object that are acquired in time t. Because momentum is nothing but product of mass and velocity. If we rearrange these terms, we can get like m multiplied by v2 minus v1 upon t. But we know that v2 minus v1 upon t is nothing but rate of change of velocity, that is the acceleration. Therefore, we can say that rate of change of momentum is equals to ma, and according to the Newton's second law, as rate of change of momentum is directly proportional to the force that is causing the change, we can say that F equals to m into a. Let us see Newton's third law of motion now, very famous law. It states that to every action there is an equal and opposite reaction, which is clearly observed from this animation. In addition to the Newton's laws of motion, let us see Newton's law of gravitational attraction also. This law states that when two particles or bodies sorry two particles or bodies are mutually attracted with each other with equal and opposite forces of magnitude given by F equals to gmm upon r square. On earth, any two objects, they will be mutually attracted with a magnitude that is given by F equals to gmm upon r square. Here g is the gravitational constant, capital M and small m, they are the masses of the two bodies, r is the distance between the two bodies. Let us say now one object is earth whose mass is capital M, and the second object is any object on the earth whose mass is m. Now the distance between them, let us try to find out. We know r is the radius of earth. We can assume capital R is the radius of earth. Small r is the distance between earth and the object. Then the total distance between the earth and the object will become r plus r. Then we can rewrite the law as W equals to gmm upon r plus r whole square. Why W? Why not F? because the force of attraction between Earth and object is nothing but the weight of the object. That is why the Ebola, it can be rewritten as W equals to GMM upon R plus R whole square. But compared to the radius of the Earth, the distance of the object from the Earth is very, very negligible. So, we can again rewrite this statement as W equals to GMM upon R square. We are neglecting the value of small r. Here, in this formula, if you observe, G is the constant value, gravitational constant. Mass of the earth is also constant. Radius of the earth is also constant. So, only variable term is the mass of the object. So, let us replace Gm upon r square with a single constant small g acceleration due to gravity. Then the expression for weight becomes W equals to small m into g, where g is equal to 9.81 meter per second square. This value of g is measured at sea level at a latitude of 45 degrees. So thank you for watching this video. In our next video, let us learn what is force and what are different force systems. Thank you. Thank you for watching.